In this video, all students will be able to articulate the difference between a linear word problem and an exponential word problem. To articulate something means to put it into words. Like if I asked you, articulate how you're feeling, you might say, oh, well, I'm frustrated because blah, 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 blah. I'm just asking you to put it into words. You're going to articulate the difference between a linear word problem and an exponential word problem. Linear word problems, we're going to move down the left side of your page first. A linear word problem follows the formula y equals mx plus b. So an example might be y equals 2x plus 3. So if I make a table of values, because I'm going to graph it next, I really only need a few points because it's going to be a straight line. It's a linear. So I'm just going to pick a few easy ones. If I took a 0 and plugged it in, 2 times 0 is 0, plus 3 would be 3. If I plugged in 1, 2 times 1 would be 2, plus 3 is 5. If I plugged in 2, 2 times 2 is 4, plus 3 is 7. You can see it just keeps going up by 2's, right? That's how linear works. So let me see if I can get these dots on here accurately. It's kind of hard sometimes. Slope of 2. All right, I did all right. I did all right. Let's get that line tool, though. Try and get that line right. Ooh. Is it right? I don't know. No. Is it? Yeah, that's a guess. That's good enough. Okay. So that's what the line would look like for linear. It is a straight line, which means it has, oh, I didn't want to cover that up. It has a slope, okay? That's really important to understand. The reason why it has a slope is because it has a consistent difference. You'll notice, again, every time it went up by 2's, it had a consistent difference. So what does that mean? It adds or subtracts by the same number as x increases. Okay, so here are some examples of linear word problems. You make $10 per hour, right? As hours go up, you add 10. That's going to be a consistent difference, or the slope. You do half of a problem every time you sit down. Like maybe you keep getting distracted. You do half of a problem every time you sit down. So every time you sit down, half of a problem. Every time you sit down, half of a problem. Last but not least, you run 2 miles every day. So as the days increase, you run 2 miles. So returning to the formula, I just want to make sure you understand what each point represents. This is your y-intercept, right? And this is your consistent difference. This is the one that it pluses and minuses by over and over and over again, or the slope, right? We know that as the slope of the graph. But the reason why it's the slope is because it goes up. Like this one goes up by 10 every time. This one goes up by a half every time. This one goes up by 2 every time. Okay, so that's your slope. Let's go to the right side of your page for exponential word problems. These ones follow the formula y equals a times b to the x, or you could just write ab to the x. An example might be y equals 3 times 2 to the x power. Now, I want you to notice I picked an equation that looks very similar. I used the 2 and the 3 again, but I plugged them into an exponential one this time. I did that on purpose, okay? So, x and y. Let's see. We'll do a few because we don't have that much room. All right. I'm going to start with the easiest one. I think you should also start with the easiest one whenever you can. That's the 0. Okay? So if I put in a 0 right here for x, if I put a 0 right in there, 2 to the 0 power is 1. I want to remind you it's 1. So this is a 1. And then you have to times it by the 3 in the front. So 3 times 1 is, of course, 3. Let's plug in the 1 next, right here. We'll put a 1. 2 to the 1 power. 2 to the 1 power is 2 times the 3 in the front would be 6. All right, I'm going to plug in this 2 right here. 2 squared, remember you do exponents first, right? Don't do the multiply yet. 2 squared is 4 times the 3 in front would make it 12. I want you to notice that 2, that base that we're multiplying by, it keeps multiplying. It's not the same amount, but it's the same multiplier. So right here, what would come next after that? Come next would be 24. We can tell that much. We know that much. Okay, so the negatives always give people a headache. I will ask you a shortcut question. If you see that's multiplying by 2 every time, what was this number before it multiplied by 2 and became a 3? It was 1 and a half. 1 and a half times 2 would give you the 3. Now, if you didn't know how to do that, I'll show you how to do that the long way. So if we plugged in the negative 1, we'd get 3 times, and I'm going to move it to the bottom. Now right here, 2 to the first power is just a 2. So multiplying across the top, you get 3, and on the bottom you get a 2. So 3 halves, or 1.5. All right, now let's go ahead and do the negative 2, just to get that other point. So it's going to be 3 times 2 to the negative 2. 3 times 1 over 2 squared, which is 4. And so we get 3 over 4. Or 0.75. Whatever you want to write. Doesn't matter. Let's go ahead and graph these. Hope you can see the dots I'm doing. It's kind of hard on here. Oh, let me see if I can change. Hold on. Can you see that one better? Yeah, a little bit better. And then I'm off the page. I use a different graph for this one. Okay, so it curves, right? Curves. Alright, so exponential word problems always look like curves. There's no slope. It's because they have a consistent ratio, right? That 2 every time it multiplied by 2. It means that you multiply or divide by the same number when x increases. Example word problems. Okay, so each hour you make 10 times what you made last hour. So that means that you get paid 10 times as much as you did the last hour. It's a pretty sweet job. All right, you do half of the word problems on the page every time you sit down. Not half of a word problem, or I'm sorry, not half of a problem, half of the problems, meaning half that are on the page. And the last but not least, you run twice as far every day. Not you run 2 miles every day, twice as far. So you're increasing your distance. So if I return to the formula, this right here is your starting number, and it also represents your y-intercept. The base is your ratio, or the thing that gets multiplied over and over and over again, and x is the number of terms. So, for this lesson, you have to ask yourself, does it go up by the same amount each time, or does it multiply by the same number each time? We're going to be reading some word problems. You have to decide if it's linear or exponential, and then you have to write the equation in the correct formula. So that would be mx plus b, or ab to the x. Okay? So here we go. Label each word problem, then write the equation. You have $200, and your bank rewards you with $10 each year. So each year you get $10. It's the same amount each year. That's going to be linear. So y equals the $10 per year plus the $200 you started with. Technically, you could also write 200 plus 10x. So my other video got cut off, and I don't know why. I think I ran out of memory. So anyways, number 2, you have $200 and your bank rewards each customer with 10% each year. So 10%, depending on how much you have, could be a different number. If I have a little bit of money, 10% is a little bit. But if I have more money, 10% is going to be more money. So this is actually a changing amount. This is a ratio. Okay, this is a ratio. So this is going to be an exponential equation. Okay, when we do an exponential equation, we're going to follow this formula, which means we have our starting amount times our ratio. If I make 10%, that's 100% plus the 10%. Okay, you could also just put 0.1 to the x power. Okay, on this section, this is where you really are testing if you know the difference between linear and exponential. I want you to try your absolute hardest. I want you to pause the video first and do numbers 3 through 8. That means you need to write exponential or linear and the equation as well. Okay? Go ahead and pause this video. So here are the answers for number 3 through 8. Number 3, exponential, y equals 0.01 times 2 to the x. I use parentheses in this equation so they didn't get confused with my decimal point, but you could also use a dot for multiply. Number 4, linear, y equals 0.02x. Number 5, exponential, y equals 75 times 1.5 to the x. I just want to make sure that you understand. You may not know how blackjack works, but if you bet 50% and you win, that means you keep all of your money and you get the 50%. That's why it's 1.5. Number 6, you have $75. Every time you sit down at the blackjack table, oh, I don't need to read it. What am I doing? Number 6, linear. Y equals 50x plus 75, or 75 plus 50x. Number 7, linear. Y equals 2x plus 50, or 50 plus 2x. And last but not least, exponential. Y equals 50 times 2 to the x. Thanks, Honey Bunnies.